Hi everyone. So we will be continuing our lesson on chapter 3, and for this time we will be working on integers and the order of operations. So we are going to define integers and graph them on a number line. We will also take a look at the different inequality symbols less than or greater than, and we're going to work on the absolute value of integers. Also, we will be working on the operations involving integers, and if ever there are multiple operations, we will also follow the order of operations agreement. So what are integers? So the integers consist of the natural numbers, 0, and the negative versions of the natural numbers. So basically, these are your natural numbers, which are your positive integers. The negative versions of them are negative integers, and then of course 0 right there in the middle. So when we talk about positive integers, we can write them in two ways. We can use the positive sign or the plus sign right in front of the number. So this is read as positive 4, or we just don't write anything in front of it as it is understood to be a positive number. So on your number line, this is the graph. This is a representation to visualize the numbers and how they are compared to each other. So you would see that 0 will always be the basis because that is the middle value. To its right are the positive numbers, and to its left are the negative numbers. So 0 is not positive, it's not negative, it's like neutral. Okay, so basically, when you are going to graph your integers, you just have to find them in your number line. So let's say, for example, here we have -3. So from 0, that's 3 units to the left. So it's going to be this point over here. So you can graph it here on the line itself, or you can graph it here on the top. Okay. 4 is positive, so you can find it on the right side. So it's going to be this one. And then, of course, 0 just right there in the middle. Okay, now our inequality symbols, less than or greater than, they tell us about the values of two numbers being compared. Okay, now if some of you are still getting confused as to which is greater than, which is less than, there's a simple technique that I can give you. The one that looks like an L, okay, L, this is your less than. Okay, so it means if this is the less than, then the other one is your greater than. Okay, so you will always remember that the pointy end of your inequality always points to the lesser number. Okay, so for example, in this case, how are we going to compare -4 and 3? So if you're going to locate, even if without your number line, you know that the negative numbers are always to the left of your number line and to the left of 0. So here we know that negative number will always be less than our positive number. If you now have two negative numbers and you're getting confused, which one is higher, which one is lower, then you can locate them in your number line and see which one is on the leftmost. So this is our -5 and this is our -1. As we can see, -5 is farther to the left, and so we can say that -1 is greater than -5. And again, similar scenario here. You have two negative numbers, okay? You have -5 and -2, okay? And still, -5 is going to be less than, so the pointy end goes to -5. And for this example, anything that is compared to 0, just remember positive numbers are on the right, which means they are greater. Negative numbers are on the left of 0, which means they are lesser. And so in this case, 0 is greater than any negative number. So when we talk about inequalities, we don't only have the less than or greater than symbols. We also have what we call as the equal to versions of those inequalities. So this is read as A is less than or equal to B. So what does that mean? When you have the equal to involved, it means that it can satisfy any of the two conditions. 2 is less than or equal to 9. Why? Because 2 is less than 9. Also, we can use 9 is less than or equal to 9. This is also possible because it satisfies the part that is equal. Okay, so you will always have two possible conditions that could be satisfied. Just satisfy one of them, and it means that that could work. Okay, so when we talk about absolute value, it's pretty much like we're talking about how far it is from zero. It doesn't matter if it is on the left side or the right side of zero. We are just looking at how far it is, its distance from zero to the number line. And pretty much, in simplest way to explain it, your absolute value will always be just the positive version, okay? Because we are always talking about the distance, it is always a positive number. So how far is -3 from 0? So as you can see, this is -3 and this is 0. So how far is that? Okay, so that is 1, 2, 3. 3 units away. And so, like I said, your absolute value will always be a positive number. So here, what is the absolute value of 5? It's going to be 5. 0, no matter what happens, that positive is not negative, it will always be a 0. Okay, so now we proceed with the operations of integers. We have the addition of integers, so we only have two rules here, okay? Number one, if they are like integers, so when we say like integers, same sign, okay? If they have the same sign, just add them, simply add them, okay? Simply add the numbers, okay? So for example, if I have, let me switch to a different color. So let's say if I have +5 plus +6, okay? This is simply +11. If I have -3 plus -15, so because they are both negatives, I just add their numbers. So this is going to be -18, all right? So if we have like integers, simply add them. Now, the second rule is if you have different signs, okay? So if you have different signs, so basically what you will do is subtract the numeric form, subtract the number part, okay? The number part, and then the sum will use the sign of the higher number, okay? So how does this work? So let me just switch this again, okay? Oh, did I get it? Okay, here. So if you have different signs, let's say we have +5 plus -9, okay? So this is a positive, this is a negative. What we do is we simply subtract the number part. So in this case, we just subtract the 9 and the 5. What's the difference? 9 and 5, if you subtract them, that's going to be a 4, okay? Now, between the two, between 9 and 5, what is the sign of the higher number? Well, 9 is higher than 5, and 9 is marked as negative. And so the sum will also take the negative sign. So +9 plus -9, that's going to be -4, okay? Let me give you another example. Let's say I have -12 plus, let's say 17, okay? So again, they are different signs, negative and positive. So we subtract 12 and 17, their difference is going to be 5. 17 minus 12, that's going to be 5. Now, between 12 and 17, we know that 17 is higher. What is the sign of 17? 17 is positive. And so this is going to be a +5. That is how we do our integers addition. Okay? Now, when we talk about additive inverses, pretty much these numbers have the same absolute value. But if you add them, their sum will be 0. So pretty much they are like opposites of each other. So you have +18 and -18. If you add them, that's going to be 0. So if you have -7 and +7, you got to add them as 0. So any number that you're given, it will always have its additive inverse. Simply find the opposite sign. So if I have negative 100, what is the additive inverse of negative 100? So the additive inverse of that would be positive 100. Okay? So like I said, any number and its additive inverse, if you add them, that will be 0. Now, let's work on the subtraction of integers. Okay, so pretty much with the subtraction of integers, to be honest, it also follows the rule. It follows the rule of your, how to call this? Pretty much like in addition too. But in general, because sometimes people get confused with the subtraction part, there's, you can always use this method, okay? So first step, change the sign of the subtrahend. Okay, the subtrahend is the second number. Okay, change the sign of the subtrahend, and then after that, change to addition. Change to addition. Okay, pretty much that's the summary of how to do subtraction. Okay, so let me give you an example. Let's say we have 3 minus negative 5. Okay, so according to the rule, it says change the sign of the subtrahend. This is the subtrahend. So this is given as negative 5. We're going to change it to become positive 5. Okay, so just switch the sign of the subtrahend, and then we change to addition. We will change the subtraction to addition. So now you have 3 plus positive 5, which is actually 8. Okay, so that's pretty much how you're going to do subtraction. Let me give you another example. Let's say we have negative 7 minus, let's say 6. Okay, negative 7 minus 6. So again, from the rule, we change the sign of the subtrahend. So this is our subtrahend. So this is a positive 6. Okay, so we're going to make it as a negative 6. Oops, sorry. Negative 6. And our subtraction sign will now change to positive. Okay, to a plus. So now we have negative 7 plus negative 6. So if you add them, that's going to be a negative 13. Okay, so let's have some examples. So as we have mentioned earlier, we change the sign of the subtrahend and then add. Okay, so we have 17 plus 11. That's going to give us 28. Simple. Now, on this case, again, change the sign of the subtrahend. So this will become positive 5. The subtraction will now change to a plus. Okay, so now we have negative 18 plus 5. Now let's go back to the rule of addition. If you are adding different signs, we know that we're going to subtract the numeric values. So 18 minus 5, that's going to be 13. Which one has the higher value? 18 is higher, and the sign of 18 is negative. So our difference is going to be negative 13. All right. And then for this last example, we have negative 18 minus 5. Can change the sign of the subtrahend. So this will become negative 5. Sorry, it keeps on doing that. And then our subtraction will change to an addition. So now we have negative 18 plus negative 5, which is going to be negative 23. All right.